A green lawn can hide a watering problem until one hot afternoon reveals every weak spot. These pale arcs are not random. They trace exactly where sprinkler coverage is falling short. Adding more minutes may deepen puddles, while the driest grass still receives almost nothing. Today, 6 clean cans will show where your irrigation water actually lands across this lawn. This simple 10-minute test replaces guesswork with measurements you can see, compare, and record. It can reveal blocked spray, tilted heads, poor overlap, weak pressure, and mismatched sprinkler patterns. The goal is not maximum watering. It is more even coverage with less unnecessary runoff. Before changing any controller, we will test one irrigation zone under normal operating conditions. By the end, every number will point toward a practical inspection, adjustment, or professional repair.
Homeowners often judge sprinklers by visible spray, but airborne water does not guarantee ground coverage.
Fine mist can look impressive, while wind carries droplets beyond the grass and onto pavement.
A rotating head may move normally, yet deliver less water because its nozzle is partly blocked. One sunken sprinkler can create a green ring nearby and leave the outer throw chronically dry.
A tilted head sends its pattern low on one side and high across the opposite edge.
Longer runtimes cannot correct poor spacing when neighboring sprinkler streams fail to reach each other.
Mixed spray heads and rotors may apply water at very different rates within one zone. Grass beside walls, trees, slopes, and driveways can dry differently despite sharing one controller setting. Compacted soil may shed water quickly, while sandy soil accepts water but stores much less. Automatic schedules also keep running after rain, unless sensors or homeowners interrupt unnecessary irrigation. Brown grass does not automatically mean drought. Disease, insects, roots, heat, and soil also matter.
That is why this test diagnoses water delivery, not every possible cause of lawn discoloration.
Test results become useful only when combined with close inspection of grass, soil, and equipment.
Always follow local watering restrictions, especially during drought declarations or seasonal municipal limits in your area. Now we will isolate one zone, because combining zones hides which sprinklers caused each reading. Sprinklers work best when neighboring patterns overlap, helping low edges receive water from another head. This planned overlap is often called head-to-head coverage in properly designed residential irrigation systems. Actual application depends on nozzle size, pressure, spacing, arc settings, wind, and nearby obstacles. Cans measure precipitation rate, meaning how quickly the zone applies water to the surface. They also reveal uniformity, or how similarly water is distributed across different parts of one zone. Averages help calculate runtime, but individual low readings locate areas still vulnerable to drought stress. High readings matter too, because they can indicate overspray, pooling, overlap, or excessive local output. Soil texture determines how quickly applied water enters the ground and how long moisture remains available. Clay-rich or compacted surfaces often need shorter cycles, separated by time for water to soak. Sandy soils usually drain faster and may need smaller applications, scheduled according to local guidance. Grass species, rooting depth, shade, temperature, wind, and rainfall all change the final watering requirement. The can test measures delivery only. It does not prescribe one universal weekly amount for every lawn.
New seed and newly laid turf need different moisture management from established, deeply rooted grass.
Dormant turf may also have different goals, depending on climate, species, and local drought policy. We will therefore use these measurements as a baseline, then fine-tune through soil checks and observation.
Choose a calm morning when wind is light, because drifting spray can distort the results.
Run the test when household water demand is typical, since pressure changes can affect sprinkler performance. Gather 6 identical, clean, straight-sided containers, a ruler, timer, notebook, and small marker flags. For strong spray heads, choose deeper catch cups to reduce splashing beyond shallow container rims.
Remove sharp lids completely. Wash each can and check every rim before entering the lawn. Wear closed shoes and keep children and pets away while sprinkler heads are operating.
Open the irrigation controller and identify the exact station serving the patchy front lawn area today. Briefly activate that station and watch where each sprinkler rises, rotates, and finishes its arc. Mark each hidden head with a small flag placed safely beside, not over, the nozzle.
Turn the zone off before placing containers, preventing sudden spray around your hands and face.
Place one container in a healthy green section, several feet away from the nearest head.
Set another container inside a pale patch where grass appears consistently thinner or duller.
Distribute the remaining containers between heads, near edges, and across the middle of the zone.
Keep every container level, upright, unobstructed, and seated firmly enough to resist accidental tipping during testing.
Do not place cans directly against sprinkler heads, where concentrated water can create misleading readings. Check the test grid from above, confirming that both green and stressed areas are represented.
Move any container blocked by tall grass, edging, garden furniture, shrubs, or decorative stones.
Set the timer for exactly 10 minutes before restarting only this single irrigation station.
Start the zone and step outside the spray path while the timer begins counting. Watch the nearest sprinkler rise vertically and confirm its stream clears the surrounding grass blades. Observe one rotor completing its arc without sticking, pausing, or spraying beyond the intended boundary.
Check whether nearby heads overlap, with each stream reaching approximately toward the neighboring sprinkler location.
Notice any mist blowing sideways, because wind can lower catches on one side of the lawn.
Look for water striking tree trunks, walls, fences, vehicles, sidewalks, or the house foundation. Inspect for bubbling around heads, which may indicate damage, loose fittings, or underground leakage. Watch the soil surface closely for runoff beginning before the 10-minute test has completely finished.
If runoff starts, note the time. Later cycles should remain shorter than that threshold.
Listen carefully for sputtering or irregular pressure changes that coincide with visibly uneven spray patterns.
Do not adjust nozzles while running unless the manufacturer specifically permits safe adjustment procedures.
Let the zone operate unchanged, because the purpose is to measure its current real performance. 5 minutes, compare visible water levels without touching, tilting, or moving any container. Continue watching the driest patch to see whether spray consistently reaches its entire surface.
As 10 minutes approaches, prepare to stop the station immediately when the timer sounds.
Stop the zone at exactly 10 minutes, preserving a clean timing basis for every calculation. Wait for droplets to settle before walking carefully between the containers and wet sprinkler heads. Photograph the full container layout before collecting measurements, creating a useful map for later comparison.
Label the containers 1 through 6 according to their positions across the irrigation zone. Measure the first container on level ground, reading water depth from the lowest meniscus.
Record the depth carefully using one consistent unit, either inches or millimeters, throughout the entire test.
Measure the green area container and note its grass condition beside the recorded water depth.
Measure the pale area container next, keeping the ruler vertical against the straight container wall. Continue measuring every catch individually, without pouring water together, before recording each numbered container location. Circle the lowest reading, because that location may explain recurring drought stress or weak growth.
Circle the highest reading too, since excessive local output can waste water or encourage runoff.
Add all 6 depths, then divide by 6 to calculate the average 10-minute catch. Multiply that average by 6 to estimate the zone's measured precipitation rate per hour.
For metric records, multiply the 10-minute average by 6 to obtain millimeters applied each hour.
Write the calculation beside the zone name, date, weather, runtime, and observed pressure conditions.
Compare each reading with the average, looking for meaningful patterns rather than tiny measurement differences.
A single extremely low can usually deserves an equipment inspection near that specific lawn position. Several low cans along one edge may indicate poor arc adjustment, obstruction, spacing, or pressure. Several high catches near one head may indicate concentrated spray or overlapping patterns there.
If all readings are low but similar, the zone may simply apply water slowly and evenly.
If all readings vary widely, adjust or repair coverage before increasing the controller runtime.
Repeat the entire 10-minute test after corrections, using the original container positions whenever possible.
Now place the recorded numbers on a simple sketch matching each container's lawn location.
The sketch turns measurements into a coverage map, making dry corridors and wet pockets obvious.
A low reading behind a shrub suggests foliage is intercepting spray before it reaches turf.
A low reading beyond a sunken head suggests grass blades are blocking the lower spray trajectory. A low reading beside a tilted head often matches the direction where its pattern falls short. Alternating high and low readings may point toward inadequate overlap between neighboring sprinkler patterns. A dry corner can result from arc settings that stop before reaching the lawn boundary. Water on pavement beside a low lawn catch indicates useful spray is missing its target.
Uniform catches with continuing brown grass suggest irrigation coverage may not be the primary problem.
In that case, inspect soil moisture, rooting, pests, disease symptoms, shade, and compaction carefully. Push a screwdriver or soil probe gently after irrigation to compare wetting depth at several points. Easy penetration in one area and resistance nearby can confirm uneven soil moisture or compaction.
Lift a small turf edge only when necessary, checking roots without causing unnecessary lawn damage.
Healthy established roots should be evaluated alongside species, season, soil, and recent weather conditions. Do not diagnose fungal disease from color alone, because many stresses create similar brown patches.
Photograph close symptoms and contact a local extension service when accurate identification still remains uncertain.
Compare results between irrigation zones separately. since different head types can produce different application rates. Never combine spray head and rotor run times automatically without first confirming their measured precipitation rates separately.
Also retest after major landscaping changes, system repairs, aeration, tree growth, or sprinkler replacement work. A yearly spring audit can catch damage before summer heat magnifies every coverage weakness.
Begin corrections by cleaning debris from the visible nozzle according to the sprinkler manufacturer's instructions.
Straighten only adjustable heads designed for homeowner servicing, and shut off water before handling components.
Raise sunken heads carefully when access is safe, avoiding irrigation lines, wiring, and buried utilities.
Trim obstructing vegetation rather than increasing pressure to force spray through leaves and branches. Adjust spray arcs so water stays on turf and away from pavement, walls, and vehicles. Replace damaged nozzles with compatible parts that match the head type and intended precipitation pattern.
Avoid mixing unmatched nozzles within one zone unless an irrigation professional confirms compatible application rates. If pressure appears excessive or inadequate, have regulators, valves, and supply limitations properly evaluated.
Poor head spacing cannot always be solved by nozzle adjustments. Redesign may require professional installation.
After each correction, rerun the complete 10-minute test instead of trusting spray appearance alone.
Use the measured precipitation rate to calculate runtime for a locally recommended application depth. Required minutes equal desired depth divided by hourly precipitation rate, then multiplied by 60. Subtract effective rainfall when appropriate, using a rain gauge or reliable local weather information. Adjust seasonal schedules as temperatures, rainfall, grass growth, daylight, and local weather conditions change. Water during permitted low wind hours, commonly early morning, while following local rules and system guidance. Stop irrigation when water begins running off, even if the planned runtime is not complete. Divide longer irrigation into shorter cycles when slopes or compacted soil cannot absorb water quickly. Allow soak time between cycles so water moves downward instead of flowing across pavement. Check soil after watering to confirm moisture reached the active root zone without prolonged saturation. Fine-tune gradually, changing only one variable at a time and carefully recording the result.
Call a licensed irrigation professional when zones leak underground, lose pressure, or contain damaged buried piping.
Professional help is also appropriate for electrical faults, valve failures, backflow devices, and major redesign. Contact utility location services before any digging that could reach buried pipes, cables, or gas lines.
Seek turfgrass diagnostic help when uniform watering fails to improve recurring discoloration or thinning.
Local extension specialists can help distinguish irrigation stress from insects, disease, nutrition, or soil problems.
Follow product labels exactly if any pesticide or fertilizer is later recommended after proper diagnosis. Never compensate for an unidentified lawn problem by adding fertilizer, chemicals, or frequent daily irrigation.
Good lawn care always begins with measurement, observation, safe maintenance, and reliable region-specific recommendations.
6 identical cans, 10 measured minutes, and 1 ruler can expose hidden sprinkler weaknesses.
Test one zone at a time, record every catch, and map both high and low readings.
Calculate the average output, then correct uniformity problems before changing the zone's total irrigation runtime.
Retest after adjustments, because measured improvement matters more than a visually impressive spray pattern.
Match watering decisions to grass species, soil, weather, rainfall, season, and local conservation requirements. When the cause exceeds simple maintenance, bring the measurements to an irrigation or turf professional.
subscribe for more evidence-based lawn diagnostics that replace guesswork with practical, repeatable home tests.